I am Simran, your host for today's session. Let me give you a brief introduction about who we are. Protrainy is an NSR CEL IIM Bangalore pre-incubated education technology startup. We are registered with Startup India, Startup Odisha, and OCL. Landing skill prerequisites which definitely fit market demand is tougher than landing a job itself. That's where we come into play. We prepare engineering students to be industry ready by training them for the essential required in the field. We believe that skill building is an extensive process which requires detailed and practical knowledge, which can be done with the help of our experienced experts. Our only aim is to build a skilled workforce for the civil engineering industry and to create thought leaders of tomorrow. Co training brings to you an evolving industry ready environment to tackle the ever lifting business scenario. As an industry platform creator, we upskill civil engineers in technical domains as per current industry trends. From theoretical concepts like structural engineering, bridge engineering, to software training like Primavera, ETABS, AutoCAD, we offer 360-degree holistic development required for a civil engineer to become a skilled industry-ready professional. We currently conducting an industry-ready long-term course on civil engineering. Can you switch off your mic? Industry-ready long-term courses.
Can you please unmute yourself, host?
Yeah, I was not able. I was not audible.
No, just now by mistake I just muted you. Please continue. You were audible.
To be updated with our upcoming amazing courses, go and follow our Instagram, Facebook, and LinkedIn profile by the name Protrainy. Now, I would like to introduce our expert, Nidesh sir, who has launched our courses to make everyone industry ready. Now, I request sir to start the session.
Thank you very much. Hey, good evening, everyone. I'm audible properly?
Good evening.
Yes, I hear you.
Yeah, thank you very much. Thank you very much, everyone, for joining the session. All right, so my name is Anuday Sachan. I have more than 3 years of experience as a planning engineer. I have taught more than 1,000 of students so far. And today in this class, we just have 1 hour. So I'll be just briefing you about the course content which we have. And I'll be briefing you the entire process, right from reading the drawings, how you will read the drawings, and how you will estimate the quantities out of that, how by reading the drawings, you'll go and perform the layout work. Just a minute, hold on, guys. Okay, so we'll just begin the session. Before just starting session, I'll request from all of you, please put your mics mute, okay? And I'll just give you the time so that you'll be able to ask the questions. So let's get started. We'll see a brief about how you will read the drawings. When you go for the construction process, you'll get a lot of different drawings. So how you have to read out from drawings and how you'll perform the work, right from the layout of site, right? And then estimating the quantities, making the bar bending schedule, how actually the work is being executed before going to the site, what are the duties as a civil engineer you have to perform, okay? Yeah, I'll just be sharing my screen, don't worry, guys. Okay, so hope you all can see my screen. Able to see my screen, guys?
You can see it.
You can see it?
Yeah.
Okay,
Yes.
all right.
Yeah, I can
All
see
right,
it.
that's
I
great.
can see
Thank
the
you.
screen.
Cool. Okay, so guys, we have a lot of different types of drawings when we actually start executing the work at site. These are some of the drawings using which you'll execute this, this work into the site, right? So this first drawing, which I'm showing you right now, is called as layout plan, center line layout plan. Hope you all have heard about this drawing. Anyone who have heard about this name? Anyone of you?
Condition layout. Yeah.
Yeah, down here you have a
Yeah.
foundation detail, but overall this drawing will be called a center line layout, right? Before executing before executing the construction work at the site, you have to perform the layout work, right? You'll just do the markings at the field, you'll dig out, you'll excavate for the foundation purpose, and then you'll do the foundation, and then you'll really start the construction. So this is the very first drawing which you have to deal on, and this is called as layout plan, right? After this, you'll perform the beams. This is called ground beam plan, right? You'll just make ground beams. Below here, if you'll see, these is the cross section, right? From here, you can just exactly find out what is going to be the BBS bar bending schedule of this drawing, right? Or these beams, right? Moving off later, this is for plinths. There's a plinth milling, sorry, plinth beams as well. Then you'll move towards the superstructure part. Then, slab beams. Okay, guys, please mute yourself. Okay, and this is for the finishing purpose. You'll have the details of door, windows, and stone work, plaster work, everything. So these are some of the basic drawings which are used, and you have to you should be able to read these drawings. Okay, after that only you'll be able to perform the real work. Once you'll learn how to read these drawings, the next phase will be to perform the layout work. Okay, and what I mean by layout, right, this is how you'll do the marking at the site for the foundation and the columns, right? And then you'll dig out for the foundation, right? Then you'll make the foundation. Okay, and once you complete the layout work, you can actually start the construction, right? And before that, you have to estimate the total quantity of each and every item, right? Let's suppose you have to do the site cleaning, you have to do the excavation to make the foundation, then you will do the sand filling, then PCC, plain cement concrete, then concrete. Okay, what is the total amount of concrete which will be used to complete the building, right? And then shuttering, you would have seen the wooden blocks, right? Then what will be the estimated quantity of concrete which will be used in pedestal columns, and same way shutterings. So this is the complete estimation sheet, right? And after this, you'll be learning how to do the bar bending schedule. Means reinforcement. You'll be calculating the total quantity of reinforcement required to construct a building, right? And you all know that reinforcement steel is provided into different structural member of different diameter, right? 8 mm dia, 10 mm dia, 12 mm dia, 16 mm dia. Okay, and we will be learning how to by reading the drawing, how you will estimate the total quantity of reinforcement. If you'll see this, right, you'll be able to find out the total amount of reinforcement in kilogram, in kg, okay, or whatever the units you just prefer, that whatever the total amount of quantity of steel will be required to make a building. So this is just the entire course about, right from reading the drawings, okay, then estimating the quantities to know how to perform the layout work. Everything is involved in this one. So let us just begin. I'll be moving up back to the first slide. Okay, guys, so this is center line layout plan. Let me just zoom in. Okay, now if you'll see this entire drawing, okay, this is a rectangular field area, right? These are the dimensions given. Okay, this is your plot where you have to construct a building, right? This rectangular portion is the plot where you have to construct a building, right? And then inside this, these are the footings, isolated footings, right? These are the footings. And inside this, the third rectangular, right? This is the column. This denotes the column, okay? So before starting the work into site, you just have to perform the layout work. You'll do the marking at site, okay? Now, how to do the marking, we'll see that, right? But before that, you should be able to read the drawings, how you will be reading the drawings, all right? So if you'll see here at the top, these are the dimensions given: 1100, 525, 2375, and these all dimensions are in mm. Getting my point? In the same way, if you'll see this side, 1562, 2900, 2650, all these are the dimensions and in mm, okay? Hello?
Hello.
Yep. Able to hear, guys?
Yeah, we are able to hear right now.
We are listening, sir.
Okay. Getting this point, guys, you just have to see what are the dimensions given at length side and in the width side. Okay. And these lines, you know, this 1, 2, 3, 4, and here at this side, A, B, C, D, these are called as center lines. Okay. Now let's suppose someone will ask you that where this footings belongs to. So what will be your answer? This is at A5. If you'll see this side, this is 5. And if you'll see this side, this is A. So this footings belongs to A5. Okay. And the name of the footing is F1. If you'll see here, here's the marking F1. And this at the base, this is C1. Okay, this is the column marking. All right. So you just got to know how to read out the footings and columns given in the layout plan. Okay. And you also know the distance. Let's suppose you were able to mark this entire rectangular field. Okay, this entire rectangular field, which is your plot area. Then you just have to mark out these center lines at the appropriate distance, which is given here. And once you'll mark the center line, you'll be able to mark the footings and column here. We'll just see after a few moments how to do all these things. Okay. But let's just move a bit down here. Okay. Now, if you'll see this footing cross section, this is the cross sectional view. Okay. Now, this is isolated footing. It have two areas. This is the rectangular area down here, and the top one is trapezoidal area. If you'll add this, both the areas, you just have to calculate the volume separately for the rectangular area, for the rectangular portion, and for the trapezoidal portion. Then you'll be able to find out the total quantity. Okay. So now just let's see how to read out this one. Okay, this cross-sectional area. So this 2000, that means 2 meter. Okay, this is the total depth. Okay, this is the total depth, 2000 mm. All right, from the ground level. This is ground level, and you have to dig a trench of about 2000 mm. That means 2 meter. Okay, now just give me an answer of one question. If you'll see this area, this is footing, and the dimension of footing is here, given here. This F1 and F2. There are two different types of footings, F1 and F2. The dimension of F1 is 1800 by 1800, and for F2 is 1500 by 1500. Okay. Now, let's suppose we just have to dig a pit for F1. Okay, and the dimension is 1800 into 1800. So what will be the size of trench which you will be digging out? It will be 1800 by 1800, or more than that, or less than that. What's your answer, guys?
I think it should be more than.
It should be more than 1800, right?
Yes, sir.
Can you just tell me the reason why? Saraz, you can't see the screen, maybe because of the network issue from your end. Okay, can you just tell me the reason why, it should be more than 1800? Any idea, guys? Anyone?
For workability
Okay.
space.
What?
I think that should be it should be more than 1800 because of workability space for when you are digging the trench. Yes.
Correct. This is one of the reason, right, for the workability purpose. Apart from that, there are a few more reasons. All right. The second one and the most important one is if you'll not leave a space, how you will provide the shuttering. Getting my point? You just have to provide the shuttering here. This is the concrete work. You'll just be providing shuttering at this side and this side. So if you'll not leave this space, you can't provide the shuttering. Getting it?
Yes, sir.
Okay. This was the second reason. Let's come to the third reason. Okay. If you'll not provide a space, if you'll not leave the space, what will happen? Okay, I just got the answer. Please mute yourself. So if you'll not leave the space, what will happen? This is concrete. And at both the end, you have soil. You have dug down there and you have soils at both the end. And if you are not going to leave the space, your concrete is going to be in direct contact with the soil. And at that point of time, it will just suck out the water and your water cement ratio will comes down, and then it will be the time when your concrete will start losing the strength. Getting my point?
Yes, sir.
Okay, so these are the three major reasons why you'll leave the space. Okay, both the side. So it could be, it will just be mentioned in the drawing what is the appropriate space which you have to leave. But let's suppose it's not given, then you can leave from 100 mm to 100 mm to 250 mm for depth of 2 meter. And if it's going beyond 2 meter, then you can give more than 250 mm space at both the side or all four sides. Okay. Now let's move further. So this was the dimension of the footings. You have got the dimension, you have got the total depth. You'll be able to, dig down the pit here. Now moving further, if you'll see there are two more dimensions, D1 and D2. If you'll see here, what is D1 and D2? So this is nothing but the depth of these two portions. This trapezoidal portion, this is D1, and this D2. Sorry, this D1 is the depth of this rectangular portion, and this D2 is the depth of trapezoidal portion. Okay. So you have got the dimensions. Now you are able to read out these things. Now let's come here. What is this RA and RB? So this is something, this is the quantity of reinforcement given in the footing. If you'll see here, the down one is called as main bars, and the top bars, which are represented as a circle, those are called as distribution bars. Okay, let me just show you this view a bit clear. Okay. Hope you guys are able to see this one, right? So this bottom one, you'll have two nets here, the bottom one and at the top one. Okay, so this bottom one is called as main bars, all right? And the top one, which are represented by circular shape, are called as distribution bar. Getting my point? Now, how you will be knowing which is the main bar and which is the distribution bar? Okay. Anyone? Okay, so see, in footing you'll have, yep, please.
The main bar is on.
Yeah, you have two types of bar. One will be main bar and one will be distribution. I'm just asking that how you will get to know that which one is main and which one is distribution.
Okay, the main bar runs
the main
bar.
I think the main bar is the one at the bottom, while the distribution bar is the one that is represented with the dots.
Yeah, that's cool. That's cool. That's right. But I'm asking, see, okay, let me just give you the answer. Okay. In this footing, right, you'll have two dimensions. One is shorter one and one is longer one. Getting my point? So the bars which are parallel to the shorter dimensions are called as main bar, and one which will be parallel to the longer one, that will be called as distribution bar. Is that fine? Is that clear?
Yes.
Cool.
Yes.
Okay, so this is how you'll recognize which one is main and which one is distribution. Okay, I'm not going into deep dimension how you'll be calculating that, but just a brief how you'll recognize. Okay, let's back to the drawing now. Okay, so now what is this? 12 pi at the rate 150 center to center. That means all these, let's just go back to this drawing. All these main bars, okay, are of 12 mm dia reinforcement. Okay, the dia of reinforcement here is 12 mm. And the center to center distance between each and every reinforcement steel provided is 150 mm. Okay, getting the point, guys? Let me just draw. That means if it is written 12 like this, 150 center to center, that means all the reinforcement steel provided at these sites are of 12 mm dia. Okay, the dia of reinforcement is 12 mm and the center to center distance is 150 mm. Correct? Okay. Okay, let us just move further. So this was the two things. Okay, you'll be able to find out what are the dimensions given here and all other stuff. Now moving up here, you have been given the details about the columns as well. Okay, what is this rectangular portion, the outer one? This is the exact column, right? This is the dimension of column, this 400 and this 250. This is the real dimension of column. Okay, outer dimension. Then you'll just subtract the clear cover. Let's suppose it's 40 mm. Okay, then this inside rectangular, this represents the stirrups. You see, stirrups are provided in the column, beam, and all of this structures. Have you seen, guys, stirrups? Have you guys seen the stirrups? Let me just show you guys. Okay, these all are stirrups. Have you seen these kind of shapes like this? Okay, you'll have different names, 2 legs, 3 legs, 4 legs. Okay, that depends on these hooks. If you have 2 hooks, that means it is 2-legged stirrup. If here in case you have 4 hooks, so it will be called as 4-legged stirrups. So these are the stirrups. Okay. Now let's go back to drawing. So this is the stirrups. Then you have total 8 reinforcement steel in the column. Okay. These 6. And what is the dimension here? These 2 outer reinforcement steel are of 16 mm dia. Okay, and one at the middle is of 12 mm dia on each face. That means this side and this side. Okay, the last two one at the corners are of 16 mm, sorry, and the mid one is of 12 mm. Getting my point?
Yes, sir.
Okay. And the mid
Sorry,
one?
I don't get it.
You didn't get, okay, let me just clear again. See, this one at this corner and at this corner, okay? These are of 16 mm. Okay?
Yes.
and this one again are of 16 mm.
Exactly.
That's clear. So total
Yes.
you have 4 reinforcement of steel which are of 16 mm dia, right? Now let's move further. This at the mid, and this one at the mid, and these 2 at the center here. These are of 12 mm dia. So total you have 4 reinforcement of 16 mm dia, and again 4 of 12 mm dia. All right.
Get it, sir. Yes.
Now the reinforcement is steel used for stirrups is of 8 mm. Getting my point? This is stirrup which I just showed you. That is of 8 mm dia. The steel which is used view of beam. Okay, this is the cross-sectional view of beam, and this is the reinforcement detail of this beam. Okay, so again, the cross-sectional view is just a bit similar to the column which you have just seen in the previous drawing. Now, I guess you'll be able to read out this. Are you able to read out this one? Can you read for me?
Uh, 300 mm by 250 mm. I think that is the using.
Sorry, will you please repeat?
The 300 mm by 250 mm.
Yeah, that's the dimension of the beam, right?
Yeah.
That means the depth of beam is 300 and the width is 250. And always remember, whenever you have been given a dimension of beam, always and always, whatever will be the large dimension, that will always be the depth. Because in case of beam, you'll always have a higher depth as compared to the width. Okay.
Yes.
So here 300 is the depth of beam and 250 is width. All right. Now, if you'll see inside there, you have got there 5, 12, 3 plus 2. All right. And bottom there is 3, 12. That means all these 3 bars are of same dimension, that is 12. Okay. And here, why you have got the 5? 3 plus 2. That means, let me just draw this diagram into the PPT. Let's just cut out this portion. Okay. Let's go back to the PPT. Okay. Good thickness, that is the outer walls, and which are having a less thickness as compared to the second one, that is the inner walls, right? 100 mm, 100 and 200 mm. Can I get? Now let's just move this side a bit. If you'll go here at the top, you'll find out the dimension of door and windows. These are the dimension for the doors. This D1, D2, D3, D4 are the dimension of doors. W1, 2, W2A, these are the dimension of windows. These are the markings. Okay. This exactly looks like the architectural plan which you draw for the house. Is that clear, guys?
Yes, it is clear, sir.
Okay. Now moving to next drawings. These are the details of. Okay, please mute yourself, guys. Can you guys please mute yourself?
Sorry, the network is fluctuating. That's it. The network is fluctuating.
No, you just please mute yourself. Okay, thank you. Okay.
Yeah. Yeah, network is bad.
So if you'll see this drawing, okay, this is layout for roof terrace beam. Okay, you have slab that is exactly similar to the roof, right? And you have slab beams. Those are called as terrace beams, right? So these are again the dimensions, reinforcement details for the slab beam. We're not discussing here about the slab, but this is slab beam. How you'll get to know this? If you'll cut down the section, this one, if you'll see here, this is an extra portion at the top. This is showing the portion of slab. This is the slab, and bottom this, below this one, this is your slab beam. Okay, so whenever you are constructing a slab, okay, so just make sure both the things, slab and slab beam, will be constructed at same point of time, right? It's not like that you'll prepare a slab first, then you'll prepare a slab beam, or just, you know, opposite of that. You are going to cast both of these at the same point of time, right? And again, if you'll see, details for the slab beams are exactly similar, which you have seen in the previous slide. Okay. Going up next, you have details for flooring. Okay. That means what are the different types of materials or the stones are going to be used at different space. Okay. So you'll see here at the bottom, at front and rear balcony. Okay. This is the flooring details. What is the type of stone you'll be using? Okay, what is the type of a stone you'll be using for front and rear balcony? What are the type of a stone you are going to use for the staircase? What are the type of stone which are you going to use for the kitchen, and like this, so forth. Okay, so on and so forth. So this is just the basic. I told you how you guys have to read the drawings. After reading the drawing only, you'll be able to do the layout work at the site, and you'll be starting your construction. Once you'll get how to read out the drawings, you'll be able to estimate the total quantity of material which is required to construct a house. And from that, you'll be able to find out the total amount or the total expenditure which is going to come to build your total building. Right? You'll be able to get the total amount, total cost, or the money you needed to build a house. Okay. So the very basic thing which you should know for all these things is to how to read the drawings. If you don't know how to read the drawings, you'll not be able to execute the work at the site. You'll not be able to find the quantity estimation. You'll not be able to find out the total estimated quantity of different materials. Yep. So you'll not be able to find out the total amount which will be required to construct a house. Getting my point, guys? Is it clear to you all?
Yes, sir.
Okay. So the very basic thing is you should first know how to read the drawing. Is it clear?
Yes, it's clear. Thank you very much.
Right. So hope you guys have enjoyed the session.
Really
If you guys have
appreciate.
any question, you can just ask. We just have a few minutes. You can ask your questions. If you have any doubt related to the course content or any question which you have read so far. Any question, anyone?
Hello.
Please.
Yes.
Yeah,
Good
please.
afternoon.
Yeah, good evening.
Yeah. All right. Good evening.
Yep.
Yes. Thank you for the lecture.
All right. Welcome. Welcome.
Yes. The screen, I can't see it again. I wanted to point out something on the screen. The one that showed the layout for the pad and the columns.
Mm-hmm.
So I noticed something there. So I quickly want to.
Yeah. So what do you want to tell?
Okay, thank you very much, sir, for the wonderful lecture. Can I
My
speak?
pleasure. Thank you. Yeah. Please go ahead.
Please, I wish to humbly make a request. I was very interested in the class. I tried all I could to follow all through, but my network has been so bad. I don't know if it would be possible for you to kindly help us with the video so that we can study and revisit it again, please.
I guess the video has been
My network
recorded.
was
You'll
very
be
bad. I
getting the
couldn't
recording
follow
as
all
well.
through. I was struggling all through.
Okay. I guess we have recorded the video, and I hope that, maybe you'll be getting the recording as well. So no need to worry about that. You'll get the content.
Okay. Hello.
Yep.
Hello. Yes. Good
Yeah.
evening. Question earlier.
Sorry, I didn't hear you.
Hello, sir.
Yeah.
Oh my God. Sorry, I didn't hear you, sir.
Yeah, I can hear you. Please.
You said. Hello, sir. You said we are going to have the recording?
Maybe, I just saw that recording was on there. So I think there will be a recording provided. I'm not sure, guys.
It's actually, the recording is on.
Yeah, recording is on. So I guess that, Protrainy will be providing the recording as well.
Okay, thank you very much, sir. God bless you, sir. I'm grateful.
Thank you very much.
Thank you so much, sir.
Okay.
Any question
Hello?
from anybody?
Yes.
Please, I want to ask
I
a
was
question.
about to ask a question. Hello.
Yeah, please, go ahead.
Yes. Good evening. Thank you for the lecture, sir. I said on your
Pleasure.
layout, the layout you showed us now, the one that showed the pad footings alongside with the columns. So
Yeah, see.
there was one that showed a cross sign looking like multiplication on top of the pad footings. So I want to know what that is illustrating. That is question number one. And then on the layout drawings, do I also, okay, are you
Let me
trying
just
to
share the, yeah. Just
Okay,
point
yes.
out what you want to say.
Yes, thank you very much. Okay, so you can see there's a cross sign there. We're having more like a multiplication sign on top of all those pad footings. So
These
I
are
want to know what.
Is this sign you're talking about, this one?
No. On top of the pad footings, as we are looking at it now. The
Okay,
F1
this
and
one. Okay,
yes.
okay, got it.
Cross
Okay, this is
sign.
just, yeah, this is just the representation, nothing else. Just the representation.
Okay.
This
Again,
means why this has been given, like, let me tell you. Okay, this is isolated footing, right? This is isolated footing, right?
Yeah.
Trapezoidal at the top. So how the view of trapezoidal from the top looks like?
Okay.
Correct? This is exactly how the top view of trapezoidal will be represented. Hope it is clear.
The top view of what, sir?
Top view of trapezoidal. Have you ever seen the trapezoidal, right? This is isolated fitting. You'll have a trapezoidal shape at the top. So if you just see from the, yeah, got it.
All right. Yep. Yes, the second one, thank you for that. The second one is on your grid lines CD and FG. I can see a difference of 75 mm.
Yeah, exactly. Yeah. Actually,
so,
not just because of the space constraint that looks like this, but if you see this number, okay, this points off exactly here. The 75 mm difference is there between C and D.
What difference is that, sir? What spacing is that in between what and what?
Okay. Let me just tell you. Let me just try to explain you why there's a difference. Okay. So you have two lines, okay, having 75 mm difference. All right. Now, why there's a difference of 75 mm? Because the center point of few footings are coming in this line, and the center point of few footings are coming in this line, the second line. So you just have to represent, you just have to take both the centers, right? Whatever the footings are here, you just have to mark center point for all the footings so that you can construct, or you can mark out for the footings and you can mark out for the columns, right? So you just have to mark out all the centers. That's why we have two grid lines here, C and D. See this. This center point is coming in this bottom D. This one is coming in D, and this one is coming in top C1. This is C. This is again D. This is again D. So just because of that, there are two grid lines, C and D.
Thank you very much. All right. Thank you.
All right. Hope it's clear.
Yeah. Thank you very much.
Okay. Okay, guys, thank you very much.
I would like
Okay,
to ask
so
a question. Welcome. Thank
yeah,
you very much for your presentation. I'd like to ask a question, Engineer Tokpa speaking. I know you didn't. I couldn't get all the presentation, but I want to confirm how you the title page, the title of the drawing. How do you rev the drawings? I don't know if you explained that earlier. Right? How many revisions and all of those things?
okay, we have not been included here revisions. The revision is a part when you are going to design the, you are just in a phase of preparing the drawings. Okay, what happened? Let's suppose at working at site, you find out that this is not exactly the thing which is going to work at the site. So you'll ask for the revision. That's how the revision of drawings goes on, right? But here we are not considering the revisions because all these are the final drawings. So you'll have at least 8 to 9 or 10 drawings maybe before executing the work at the site. You just have to know that how you are going to read these things. So revision exactly the part when you are in a drawing phase. When you are preparing the drawings at that point of time, there will be a revision just because of the scope change. Maybe the client which is the client is asking something different at different point of time, or maybe
Okay.
the one which has been represented as the plan or the drawing that is not possible to execute at the site. So you'll do the revision at that point of time. All right. So all these finals, these drawings which I have just shown you, all these are the final drawings. We haven't considered the reviews there, right? What was the second question?
Thank you. Thank you. That's all. That's all from me. Thank you.
All right, guys. So we're just having 1 hour. We were just having the 1 hour, so it was, absolutely, it was not possible to, to just give you the all details, right? But I just try to explain you the overview, what will be the complete course contents, and how you just have to start, right? You have to start from reading the drawings. You have to start how to do the layout work at site, how to estimate the quantities and all. Then only you'll be able to become a proper civil engineer. You'll be able to work out in this industry, right?
Thank you very much.
Doubts?
Any doubt, guys? I hope you can close the session. Yes or no? Okay, thank you, everyone, guys. Good day. Take care. Bye-bye.
Thank you everyone for joining the session.
Thank you
I
very
hope
much, sir.
that the session was knowledgeable and helpful. Thank you everyone. Good night.
Yes.